Hi there. I thought we'd take a look at a couple of free response questions. These are going to be very similar to those that you might see on the AP Calculus exam. I'm going to switch our views so that we can see my calculator because these questions are calculator driven questions. So you'll see right below here that you can see what I'm typing into our calculator as we work through these problems. So let's take a look at the first one. We're being told that a car company introduces a new car for which the number of cars sold is given by this formula here. And T is the time in months. So we're being asked for what is the value of S prime of T, S prime of 2.5. Now, this is something where I'm going to use my calculator. I'm going to go ahead in Y1 and put in this function, being very careful that 9 over T T plus 2, I'm going to have to put that in parentheses. And then you can close everything really good. And then you can graph if you want. You might do a zoom 6 just to get a standard window. I'm not really concerned if you get to see anything or not because I'm just going to use one of the features of the calculator. So I'm going to do second trace, and we're going to choose option number 6 for dy dx. I want you to notice that it doesn't appear like anything's happened, but if I'll type in the value 2.5, did you notice that the x equals appeared at the bottom? And so when I press enter here, it's going to tell me that the derivative at 2.5 equals 133.333. Now remember with AP, you need to um, round to 3 decimal places. So that's very, very important. Keep that standard every time you're answering AP-like questions. And then it says, using correct units, explain what this value represents in the context of this problem. Okay, so since S prime of 2.5 is positive, that means that the number of cars, that was S, sold is increasing when T equals 2.5, and that's in months. Okay, so did you notice that I used the correct units? I said that. And then I also explained what this means. Because it's positive, it means that those number of cars being sold is increasing, and that's important to include as well. Okay, look at B then, says find the average rate of change of the cars sold over the first 12 months. Include correct number of units. Explain what this value represents in the context of the problem. So average rate of change, if you've seen some of my other videos, you know I refer to this as the slope algebra way. So this is where we're going to find the slope between t equals 0 and t equals 12. Now I'll need those y values. I'll need the y values at 12 and the y values at 0. So I can do my y2 minus y1 over x2 minus x1. Now, friends, remember, we have our calculator. So I'm going to use the feature on the calculator, second trace, and this time I'm choosing option number 1 for value, and I'm going to put in 12. This is going to give me, well, and I think it's because we are not in that range. So did you see how I got a window range error? So I'm going to go to my window range. I'm going to make sure that x equaling 12 is definitely on this window. I'll even go to 15. Give it a second to graph. And then we'll use the second trace value option. Second trace number 1. And I'm going to put in 12 there. Look at the bottom there. It's telling me that the y value here is 1307.1429. Okay. Then I'm going to do the same thing for when t is 0. So I'll do a second trace number 1 again, and this time I put when x is 0, and I get 150, and that's over 12. Now I'm going to go back to my home screen, second mode, and this is where I'll just do my calculation here. 1,307 point, and friends, did I round to 4 decimal places? I think I did. Let's fix that. Let's just use it to 3. 143 minus 150. I'll go ahead and press enter and then divide by 12. Okay, so that gives me 96.429. Okay, this is the average rate of change. Okay, so that means since the average rate of change is positive, the number of cars being sold over the first 12 months, see the difference? On the first problem, I told you at t equals a particular value. This time we're saying over the first 12 months is changing at a rate of 96.429 cars per month. Okay, we made sure to include the units as well. All right, letter C then. Is it possible for a value of C such that S prime of C equal to the average rate of change? Friends, this is all coding for does the mean value theorem apply? I recognize it because it used even the C, the same letter that we use in the mean value theorem. So it's saying, does mean value theorem apply? So refresh your memory. Mean value theorem requires that the function be continuous and differentiable on the interval from 0 to 12. Okay, so is it continuous from 0 to 12? Well, I see I have a denominator, has a problem when t equals -2, but -2 is not on this interval. So we seem to be good there. Continuous. I don't see any corners or cusps or discontinuity. So I think we're good here. So we'll say MVT, mean value theorem, can be applied because S of t is continuous on the interval from 0 to 12 and differentiable on that open interval. All right, so yes, it can be applied. Now, give a reason for your answer. Here we did. And if such a value exists, find it. Okay, so now we need to find what is that value that's guaranteed by the mean value theorem. So what we need S prime of C equal to the slope the algebra way. Now, friends, here's the beauty of what I love about AP. We already found that right side. We did that back in part B. So you can use your same answer that you found here, but we need the derivative. So we need to go find that. Now, this does not look very pretty to work with, but I'm going to go ahead and make it into a common denominator inside of that fraction because I think that might be a little bit easier. I'm just multiplying the 5 by a t plus 2. Because I think, like I said, that's going to be a little bit easier to do a quotient rule with. Okay, so this is what I'm going to take the derivative of. I'm going to have that 300 in front, and then I'm going to do a low d high minus high d low. I'm going to do a low, which is t plus 2. times the derivative of the top, which is a 5, minus the top, it's a 5t plus 1, times the derivative of the bottom, which is 1, all over the bottom squared. Now I'm going to clean this up just a hair because remember, that equals 96.429. So let me do a little bit of distributing. 5t plus 10 minus 5t minus 1 all over t plus 2 squared. And then I've got, notice those 5t's are canceling out. I've got 10 minus 1, which is 9. All right, and now we've got to solve this. Now, you have your calculator for this question. So I'm going to encourage you to please use it. Okay, let me show you what I mean by that. Let me do one more step. I'm going to go ahead and divide by 300. It's going to make my calculator work just a little bit easier. But friends, I want you to notice I'm not rounding, or I'm not going to calculate that. I'm going to leave it just as it is. Because watch what I'm going to do. I'm going to flip both equations. The reason I'm going to do that is to get that variable in the numerator. Oh, and you know what? I didn't do that. Let's do it. It's 300 over 96.429. Here's why I did that. I'm going to y equals. I'm going to put the left side of my equation into y1. I'm going to put the right side of my equation into y2. And friends, what I'm going to look for is the intersection of these two. So let me graph that. Remember, that's the first one. That's the left side of our equation. There's the second one, the right side of our equation. I need the intersection. Now remember, there's two intersections I see there, but only one of them will fall on this interval. That's the only one I need. So second, trace option number 5, and then press enter 3 times. And notice you only need the x value, which is 3.291. And that's in months because remember t was in months. And that's how I apply the mean value theorem, but I use my calculator to do some of the heavy lifting in the problem. And that frees me up then to just do the analysis. All right, let's do one more. As I said before, we're focusing on questions that are very much like AP questions you're going to see. Love the chart approach. We're told F and G are differentiable, and G is increasing. Super important. It means it's only increasing. The table gives the list of functions and first derivatives, and then we're told that h of x is defined as f of g of x minus 6. So let's write an equation of the tangent line when when x is 3. So we need the derivative. So we need chain rule. That's outside times derivative of inside. And we need that when x is 3. So I will do that substitution here. And then we're going to the chart to be able to find these values. So g of 3 is 4. And g prime of 3 is 2. And then f prime of 4 is 3. So we know that h prime of 3 equals 6. That's our slope. Now also remember we need the point. So we need h of x when x is 3. So we're going to plug in 3 here. G of 3 we'll have to go get from the chart. So let's look for that. G of 3 is 4. So I need f of 4. F of 4 is -1. So my y value is -7. So I have this point 3, -7. I have a slope of 6. So let's write the 3, -7, and a slope of 6. There is my tangent line. If you've seen any of my videos, you know I love to color up my math here. All right, now B, find the rate of change. Okay, that's slope algebra way. So we've got h of 3, we need the y values, minus h of 1 over 3 minus 1. Okay, whew, let's do it. F of g of 3, and then minus 6, minus f of g of 1, and then minus 6. Did you notice I put that in a parentheses so that I would be sure to distribute the minus? Okay, g of 3 is 4. So I've got f of 4 minus 6 minus g of 1 is 2. So I've got f of 2. And then distribute this minus is going to give you a plus 6 there. Now look for f of 4 in your chart. F of 4 is -1. Notice your 6's cancel. Minus f of 2. F of 2 is 9. And so -1 minus 9 is -10. Divide by 2 is -5. So my average rate of change is -5. Okay, now let's look at explain why there must be a value of r between 1 and 3 such that h of r equals -2. Okay, so remember when you're guaranteeing a value for the function, you are either guaranteeing it with intermediate value theorem or extreme value theorem. The Rolle's theorem and mean value theorem guarantee a value for the derivative. So in this one, we're using the intermediate value theorem. So look at h of 1. H of 1 from our previous problem turned out to be, well, let's just run it through real quick. G of 1, G of 1 was 2. F of 2 was 9. So H of 1 is 3. Okay? Now, let's find H of 3. G of 3 is 4. So now F of 4 is -1. And so you get -7. Now, remember, H of x is continuous. It's continuous. So that guarantees us, think about what we have here. If I just kind of just do a little sketch here, I have 1, 3 up here, and I have 3, -7. If this is continuous, you have to have all values between those two. That means you have to have a value when the y value is -2. Now, how do we say that? We say since h of 3 is less than -2, it's less than h of 1, showing that the y value of -2 is between the two y values on our interval, there must be a value r so that h of r equals -2. Okay, one last one. Look at D. D says, okay, explain why there is a value of C between 1 and 3 so that the derivative equals -5. So that the derivative equals -5. Remember, that when you're guaranteeing a value for the derivative, it's Rolle's theorem or mean value theorem. Rolle's theorem guarantees the derivative equals 0. Mean value theorem can guarantee that it means equal to the average rate of change. Okay, so we have to say, since h of x is continuous and differentiable, on the interval from 1 to 3, there exists a value of c such that f prime of c equals the average rate of change. On 1 is less than c is less than 3. Okay, so f prime of c has to equal that average rate of change. Now, friends, we already found the average rate of change back in part B, which was -5. Okay, so save yourself the time. Don't work through all of that calculation to just find an answer you already found. So I hope this helps. Free response questions are definitely something that you can practice to get better at. Really look at using previous answers to help you with the later questions. That will save you a lot of time on the AP exam. Well, friends, I hope this helped with a couple of practice ones here. Feel free to leave in the comments there if there's something other you would like me to make a video of or a topic you're not sure about. I'd love the opportunity to help. Bye for now.